Bismillahirrahmanirrahim. Assalamu alaikum, dear students. We are now starting the second lecture for the 10th week for wireless and mobile communication, and we are continuing the discussion of previous lecture, which is related to multiple access techniques for wireless communication. In our previous lecture, we have talked about frequency division multiple access and time division multiple access, and we had a basic introduction related to spread spectrum multiple access techniques. In today's lecture, we would discuss the different spread spectrum multiple access techniques and other multiple access techniques that are used for wireless communication. So if you recall, we discussed that there are two main types of spread spectrum multiple access techniques. First one is named as frequency hopped multiple access, and second one is named as direct sequence multiple access, which is commonly known as code division multiple access or CDMA technique. So let us start our discussion on these two techniques. So first we start with the frequency hopped multiple access. In frequency hopped multiple access techniques, in such systems, different carriers they have different frequencies. They are assigned different frequencies in a pseudo random fashion, and different users, they are allowed to change the frequencies in a pseudo random fashion in a wideband channel. So what happens, the overall digital data is broken into a uniform sized burst, and each burst is transmitted over different carriers, and after some time the carrier may hop to another frequency or change the frequency by using that pseudo random code. It must be noted that the instantaneous bandwidth of one transmission burst is actually smaller than the total spread bandwidth. So one instantaneous bandwidth is actually occupying a small portion of the total spread bandwidth, but as the signal hops to other frequencies, in that case the overall spreading bandwidth would be utilized for transmission. For receiver side, we use a locally generated PN code which is used to synchronize the receiver with the transmitter frequencies, so that the transmitted signal can be recovered at the receiver side. You must note that in frequency hopped multiple access technique and the traditional FDMA system, they are slightly different, because in FDMA system the allocated frequencies, they remain same throughout transmission, but in frequency hopped system the signal changes the frequency channel at rapid intervals. So there is a hop from one channel to another after certain time duration. Because of this frequency hopping and use of this pseudo random code, this frequency hop system provides a level of security in overall transmission, and it is not very easy to capture that signal for unauthorized users. The frequency of signal is also immune to fading to some extent. However, we generally use error control coding and interleaving to protect against errors caused by deep fades. This is an illustration of a frequency hopped multiple access system. You can see that we have used a PN code which assigns a certain frequency in the entire frequency bandwidth, channel bandwidth, which is a wideband channel, and this frequency hopped code is actually changed to another code. So in that particular pseudo random fashion, we see the hopping to other PN codes after this hopping period. So during this hopping period, you can see that the code hops to a variety of different frequencies. Okay, let us now move on to the next multiple access technique, which is code division multiple access technique, or direct sequence spread spectrum multiple access technique. In CDMA system, we use a very large bandwidth signal, which is known as the spreading signal, to spread a narrow band message over a wide spectrum. So this spreading sequence is actually a broadband signal with a very narrow time duration bits, or very narrow time duration signal, which is generated in a pseudo random fashion, and this sequence is used to spread the narrowband signal over a wide frequency. So this spreading sequence is basically a pseudo noise code which has a chip rate which is an order of magnitude greater than the data rate of the message, and because it has a very high data rate, so it occupies a larger bandwidth as compared to the narrowband message signal. For detection purposes, the receiver needs to know this pseudo noise code, and it decodes the signal by using time correlation. In CDMA system, each user is assigned its own pseudo random code, and different pseudo random codes, they are orthogonal to each other approximately. Ideally we want to have orthogonal codes, but in some cases they are not exactly orthogonal, but approximately they are taken as orthogonal codes. The receiver generally performs a time correlation operation, and when the codes are exactly matched, in that case the signal is decoded correctly. Otherwise the signal would give a low correlation, and eventually it will remain as the noise signal or spreaded signal in the wide bandwidth. This is an illustration of code division multiple access. If you take out see this first type, you can see that we have a message signal which occupies a larger time duration. That means it occupies a smaller bandwidth, so it's actually a narrowband sequence. This data symbol is multiplied by the pseudonoid sequence, which is at very shorter time duration sequence, or from bandwidth point of view it occupies a relatively large bandwidth. So eventually we get a spread spectrum signal which has to be transmitted over the channel. So once the signal gets transmitted over the channel, it is received at the receiver side, and demodulator it calculates the correlation between the locally generated the PN sequence and the received code. So it will correlate the received signal and the locally generated PN sequence, and if this locally generated PN sequence is same as the transmitted PN sequence, in that case we get a high correlation and the overall received signal is recovered in its original form. However, if we try to recover some unintended signal, or if we try to recover with some unmatched PN sequence, in that case the correlation between the received signal and the PN sequence would be a small number, and because of the low correlation we would not be able to recover the original sequence, and the received signal will remain a spread spectrum signal which appears like noise to the receiver. So this is how the code division multiple access receiver works. It generates a local copy of the pseudo noise sequence which is used to spread the signal in the first instance at the transmitter side, and gets and calculates the correlation with that locally generated copy of the PN sequence, and if the PN sequence matches with the transmitted side PN sequence, in that case the overall signal is recovered in the original form because of having a high correlation. So let us discuss some important features of CDMA multiple access techniques, for division multiple access technique. In CDMA systems, the overall bandwidth is relatively large, so primarily this CDMA system is not very efficient when we talk about single user or few number of users, because each user needs to occupy a large bandwidth. But when we talk about multiple user system, where we have to multiplex many different users onto the same frequency, in that case this system becomes relatively efficient, becomes very efficient, because many users can be accommodated in the same frequency band. So in CDMA system, all the users, they share the same frequency band. The difference is the code, PN sequence code, which is allocated differently to different users. In CDMA, the duplexing may be time division duplexing or frequency division duplexing, so both types of duplexing can be used for the CDMA systems. If we compare the CDMA system with TDMA and FDMA, we would see that the CDMA does not have a soft capacity limit. In FDMA system, we generally have a specific capacity limit, for which, if you recall, we took some problems in the previous lecture as well. So we can calculate the total number of users that can be accommodated in a specific type of system. But for CDMA, there is no specific limit on the number of users that can be accommodated in a system. What happens when we are using a CDMA system, and if we if we add more users to that particular system, in that case those users would increase the noise floor for all users. So addition of users actually results in in increase of the noise floor, and eventually at some instance the number of users increased to such a level that the noise floor becomes so high that it cannot be tolerated. So we cannot add more users. So alternatively, if we try to decrease number of users, the noise floor goes down, and we get better performance. So actually, addition of users comes with the cost of a little bit performance, and we do not have a strict restriction on the number of users that can be accommodated in the CDMA system. Because of the wideband system, the multipath fading does not affect significantly in this CDMA systems, because the CDMA system is basically a wideband system, and multipath fading generally affect a portion of that spectrum, and eventually when the signal is recovered at the receiver side, the overall effect of fading becomes negligible. One important thing regarding CDMA is that the chip duration which is used for spreading purposes is very small, and because of the small chip duration, the correlation with different multipath components becomes the correlation between other multipath components, it becomes low value. So the correlation is low when you correlate with a copy received through a multipath. So what happens, we sometimes use a rack receiver. A rack receiver is actually you can think of a rack receiver as multiple receivers arranged in a fashion that each receiver recovers different multipath components, and because of the signals extracted from different multipath components, and we can later on combine those signals, we can get a better quality signal from using this rack receiver. So generally, because of having this small chip duration, we are able to use rack receivers, which generally improves the overall performance of the system because of the possibility of combining different multipath components. Secondly, in CDMA systems, we generally have soft handoff. From soft handoff means the signals, they are not directly changed from one base station to other. What happens, the MSC monitors the users from more than one base station, so it monitors the signal strength coming from different base stations, and eventually it decides the best signal which is coming from all those base stations without having a hard handoff in the system. There is one problem with this CDMA system, which is named as self-jamming. As I mentioned that we need to use the orthogonal codes when we try to generate this code division multiple access system. These orthogonal codes, sometimes they are not exactly orthogonal, and when they are correlated with the signal, the result may not be as low as needed. So whenever we do not have exactly orthogonal codes, in that case we may be having some interference from the other signals which cause this self-jamming. Also, this CDMA system also suffer from the near-far problems. Like we discussed in our initial lectures, near-far problem also affect the CDMA system, and for that purposes we sometimes need to use a strong power control onto the for controlling the transmission power of each of the mobile, so that we do not significantly get this near far problem. So this brings us to the end of the discussion onto the three most commonly used multiple access techniques, which are frequency division multiple access that we discussed in our last lecture, and the time division multiple access, which we discussed in last lecture, and third, which we discussed today, is the code division multiple access CDMA technique, which is a spread spectrum technique. Although these three are the most commonly used multiple access techniques, but there are some other multiple access techniques which are also used in wireless communication. From those multiple access, two common techniques are packet radio based multiple access and space division based multiple access. So let us discuss these two multiple access techniques. So let me start with the space division multiple access. In space division multiple access, actually we provide multiple access to the user by having different radiation beam patterns which are directed towards that particular user. So primarily the user's occupancy is separated in space surrounding the antenna. So we generally control the radiated energy for each user in the space, so that it does not interfere with other. And for that purposes, we generally in initial applications we generally used sectorized antenna, but now we are gradually shifting to the adaptive antennas, so that these antennas can steer the energy directions for many users, so that each users they get its own steered beam, so that it does not interfere with other users. So this is the illustration for this space division multiple access technique. You can see that we have different beams which are focusing on different users. So this beam is providing coverage to that particular user. The other beam is providing access to another user, and third beam is providing access to another user. And these users, they are spatially at different locations, and these spot beams they are providing access to the base station, so that they do not interfere with each other. So it must be noted that the different areas which are covered by antenna beams, they can be served for using the same frequencies, or it may be possible that we use different frequencies for different beams as well, as we also do in the FDMA systems. So it is important that base station is made to specially filter each desired user, so that more energy is detected from the each subscriber. We need to use proper filters so that the reverse link for each user is improved, and the low power is required for the transmission purposes in this space division multiple access type systems. Okay, now let us move on to the last topic of today's lecture, which is packet radio based multiple access. The packet radio access technique is actually an uncoordinated technique, or minimally coordinated technique, in which different users they do not know, they do not coordinate to transmit the signals over the common channel. So actually each user is transmitting or trying to access that particular channel in a random fashion. So in packet radio access technique, many subscribers they attempt to access a single channel in an uncoordinated manner. So what happens? A user it waits whenever the data is available, so it attempts to transmit the data, and if there is no other transmission going on to the channel, in that case the transmission becomes successful and data is received at the receiver side. But sometimes other user it may have another data available, so whenever the data of second user is also available, it will try to transmit the data onto the same channel. So first user is transmitting the data onto the channel, and at the same time the second user gets the data as well, and it attempts to transmit the data. In that case both the data packets would collide with each other, and the transmission would not be successful, and the receiver would not be able to recover the message. So this technique is actually based on this burst transmission scheme. User waits for the data to be available, and as soon as the data is available, it transmits the data in a burst transmission form. However, there is possibility of having collision. So if more than one users or more than one transmitter they attempt to transmit the data onto same channel, in that case there would be collision, and the base station receiver it sends the confirmation for correct reception. So it will send an acknowledgement signal which indicates that the data was received correctly, or it sends a negative acknowledgement which indicates that the data was not received correctly, or which is actually indicating that there is some collision happened during transmission, and the base station did not get the data correctly. So from the description you may realize that this packet radio multiple access technique is very easy to implement, because there is no coordination needed among different users, and each user can transmit data whenever the data is available. But because of the possibility of having these collisions, the overall spectral efficiency is low in such type of schemes, and generally it induces different types of delays in the overall transmission. So in packet radio techniques, actually the users they have to use a type of a contention technique to transmit over a common channel. Because of having a possibility of collisions, so there is some technique need to be incorporated for retransmission whenever there is a collision. So say for example, a commonly used protocol in packet radio is named as Aloha protocol. So what is the technique used in Aloha protocol? First of all, the subscriber would transmit the data as soon as it is ready. So as soon as the transmitter gets the data and it is ready for transmission, it will transmit it. And after transmitting, the transmitter or user would wait for the acknowledgement. So it will see if it gets the acknowledgement feedback from the receiver. If it is acknowledged that the data is correctly received, in that case there is no need for further action. But if it gets the negative acknowledgement, that means if there is a collision during transmission, in that case this subscriber will wait. It will not retransmit the data at the same time, because at that time there would be some other transmitter is transmitting. So it waits for a random amount of time and then retransmits the data, and this process continues until it reaches a successful transmission. So it will retransmit the data, again wait for the acknowledgement signal to get from the receiver. So if you get the acknowledgement signal, in that case it's it has a successful transmission. And if it does not get the acknowledgement signal, or it gets a negative acknowledgement, in that case it will again wait for a random amount of time and then retransmit. So this process will continue until the user gets a successful transmission. The overall advantage of this packet contention technique is that we can have large number of subscribers. They can share the channel, and virtually there is no overhead needed in the system, because there are no synchronization bits required, or there are no other framing bits needed in that particular case. So the data is transmitted without any overhead. So for this type of packet radio technique, we generally use two performance metrics. One is named as throughput, which is defined as the average number of messages which are successfully transmitted per unit time. So how many messages we transmit per unit time, which are successful transmission, is named as throughput. Generally it is measured in erlangs. Second performance metric is the average delay which is experienced by a typical message burst, because for each transmission there is delay, and also if you add the waiting time as well, so there becomes an average delay in the transmission. So this average delay is also a performance metric. We generally want to have high throughput and low average delay. So based on the type of access technique, these contention protocols, they are categorized in three categories. First one is named as random access, for which the Aloha is an example that I discussed, because in this random access there is absolutely no coordination among the users, and the messages are transmitted from the user as they arrive at the transmitter. There is another technique which is called scheduled access. In case of scheduled access, there is a coordination among users in a manner that we divide the time slots, time instance into different time slots. So each user is allowed to transmit on the start of the time slot only. One of the example is named as slotted Aloha. In slotted Aloha, what we do, we divide the time into equal time slots. Generally these time slots, they have length which is greater than the packet duration. the subscriber, they have synchronized clocks in order to determine the start of the time slots, and they transmit the message only at the beginning of a new time slot. So the message is only transmitted at the beginning of the time slot. So if more than one users they transmit at same time slot, in that case there will be collusion. But if two users they do not transmit at the same user, so there will not be any collusion. So this results in a discrete distribution of packets. So you have a packet at the start of a time slot, then next time slot, and so on. But as the users they have no coordination among themselves, so there is a possibility that more than one users they transmit at the same time slots, which results in collusion. But because each user is transmitting at the start of the time slot, in that case we would not have partial collusions. So in this technique, in slotted aloha, we would not have partial collusions. So this type of technique is generally called scheduled access technique, where we have allotted time slots for the transmission of different data packages, and there may be some hybrid schemes which are combination of these random access and the scheduled access. So for the performance metric, as I discussed, one of the important performance metric for different packet radio systems is the throughput. So what is the throughput? So this if we assume that lambda is the mean arrival rate, that means how many packets, the number of packets which arrive per second. So lambda shows a mean arrival rate in packets per second, and tau is a packet duration, so again in seconds. So in that case the traffic occupancy of the system, of the network, whatever the traffic occupancy is there, is given by this relationship R is equal to lambda into tau. This is the same relationship that we have previously discussed when we were talking about the Erlang Erlang traffic in the Erlang B and Erlang C systems. So this is traffic occupancy. So the when we talk about the throughput, which gives the successful transmissions, so this throughput is actually defined as this traffic occupancy R multiplied by the probability that there is no collision, because the successful transmission would only occur whenever we do not have any collision during the transmission. So if we evaluate this probability of no collision, in that case for pure aloha system we get the throughput to be equal to R into e raised to power minus 2R, and for slotted aloha systems we get the throughput to be equal to R e raised to power minus R. So this is the throughput that we get from the aloha or slotted aloha systems. Let us take a simple problem. Actually I'm not going to discuss the solution of this problem. What I want you to determine is the maximum throughput that can be achieved from the aloha or slotted aloha protocols. So what I want you to find the maximum value of this throughput for these two types of systems, pure aloha and slotted aloha systems. So how can you calculate the maximum value, because this throughput is actually dependent on this traffic occupancy, which is given as R. So you must find the expression that maximizes this throughput, and in order to do that, what we can do, we can differentiate this expression with respect to R. So we need to calculate the derivative with respect to r and then equate it to 0 so that we get the maximum value of t. Similarly, you can find the maximum value of throughput using this expression by differentiating and equating to 0. So if you calculate for Aloha, you would see that the maximum value would come as 1 upon 2 e raised to r minus 1, which is 0.184 Erlang, or actually efficiency is 18.4% only. For slotted Aloha, you would see that this comes out to be e raised to r minus 1, which is 0.368 Erlangs, that means 36.8 Erlangs, and you can see that by dividing the system into time slots, we get a significant improvement in the maximum achievable throughput from that Aloha system. Okay, another variant of this packet radio system is named as carrier sense multiple access system. In case of carrier sense multiple access system, the transmitters or users, they are allowed to monitor the channel. So actually whenever a user intends to transmit the data, it first monitors the channel and tries to listen to the channel to see if there is any other carrier present in the channel, or if there is any other transmission going on in the channel. And if there is no transmission in the channel, or it finds the channel is idle, in that case the user starts his transmission. Otherwise it will hold the transmission for some amount of time, and then it will again listen to the channel to detect the carrier, and the transmission would be achieved only if the channel is idle, and that means there is no transmission present in that particular channel. If you compare this technique with Aloha or slotted Aloha and slotted Aloha techniques, they do not have capability to listen to the channel before transmission. So actually the transmission in Aloha or slotted Aloha is done on random basis. They do not monitor the channel state, but by listening to the channel before engaging in any transmission, the overall efficiency gets improved. However, there is some delay associated with that, because before transmission the transmitter has to detect whether another transmission is going on in that channel or not. However, this carrier sense multiple access techniques do not avoid all types of collision, although it reduces the probability of having collision, but it does not avoid all collisions, because there is a possibility that two users they may for example, they may sense the channel at the same time, and both of them, they find that the channel is idle, and they start transmission simultaneously, eventually ending up in a collision. So still there is some possibility of collision in CSMA systems, but still it provides an overall improvement in the efficiency by listening to the channel. In addition to the previously discussed performance metrics, we also use two more important parameters in this type of systems. First one is known as detection delay, which is the time required for a terminal to sense whether or not the channel is idle. So and another parameter is the propagation delay, which actually measures how fast a signal travels from transmitter to the receiver. So these two are important parameters related to this CSMA based packet radio protocols. So this brings us to the end of our topic on multiple access techniques. We have discussed different multiple access techniques that we use in wireless communication systems, starting from FDMA to TDMA, CDMA, and then we discussed two other techniques, which are space division multiple access and the packet radio based multiple access. So we stop our discussion here, inshallah. Thank you all.